So let's look at some of the answers to these questions. First of all, question 1, and you're given the structure of nylon. Here's the structure of nylon, and if you look closely, you'll see two special groups here and here, and these are called amine groups. And hence we think of nylon as a polyamide. If we now look at the basic reaction when we're making nylon, you're given this molecule, which again has an amine group on both ends, and because of that we call that a diamide. So di meaning two, amide has got two amine groups, and we add to that a carboxylic acid. And again, if you notice on this, there are two carboxyl groups, one on each end of the molecule. So maybe you can guess we call this a dicarboxylic acid because of the two COOH groups. This diamide, if you count up the carbon atoms, you'll see there are 6. For 6 we use hexa meaning 6, and it's methyl group, so it's hexamethylene. Now I said diamide. The dicarboxylic acid, the common name that's used usually in industry is adipic acid, so this is called adipic acid. So if we now look at the full equation for that, let's take a look at that. We've got the hexamethylene diamide, and we can show that simply like this. We just take typically the R, and we know at each end we've got the amine groups, NH2 at one end, NH2 at the other end, and this is the diamine, of course, diamine. And we add to that a dicarboxylic acid, which looks like this, of course. So that's our dicarboxylic acid, and we're producing the nylon structure. If we look at that, we can see that we've got a double bonded oxygen. We then have the R group and another double bonded oxygen. We then have the amine group, and of course we said it's a diamine. And we may want to mark these to show that this R group, let's mark it like this, let's go a little star, so that's from the diamine, and the other one is from the dicarboxylic acid. So, as we say, we've got the diamine, the dicarboxylic acid, and if you look closely at what's been happening, you can see that we need some water to come off. Let's see, have a look, see if we can find that. We've got here OH, we've got here OH, and from the amine groups we've got 2 H's. So we've actually got 4 H's and 2 oxygens. And of course you've got 4 hydrogens, and we've got water, so we need 2 molecules of water. A typical condensation reaction with water coming off, and of course the product here is nylon. Let's move on and look at question 2. Question 2a, you're asked, what is the name given to compounds that have the same molecular formula but different structural formulas? We know that anyway, it's an isomer. And then B, 2b, says deduce the structure of vinyl alcohol and hence suggest the structure of ethanal. Okay, let's take a look. Let's take a look first of all at vinyl alcohol. And if you look at in the text, you're given the PVOH. You see the structure is given as CH2, CH with an OH group here. Of course, that's what makes it an alcohol. And N. So that's the monomer that makes up this polymer. And if we look at the basic formula for that, it will be C of the vinyl alcohol now, the C2H3OH. And if we look at the structural formula of that, we have C, another C, 2 carbons, we have our OH group, we have a hydrogen here, so we've got 1, 2, we've only now got 2 hydrogens left, so here and here. So we've got a problem. These 2 carbon atoms only have 3 bonds. So the solution, of course, is we put in a double bond between the carbons. And if we look at the modern name for vinyl alcohol, and this is one of the reasons why these older names have been changed, this is actually called ethanol. And if you remember back to alkenes, alkenes have double bonded carbon atoms. If we then look at the second part of the question, we're looking at ethanal, and back to the name alkane with this A here, tells us there are no double bonded carbons. And so we must have the ethanal, that's the basic formula, CH3, CHO. And again, if we build this together, we can see that the formula, the structure, will be like this. 3 H's, a double bond to the oxygen, and a single bond to the hydrogen. And if we look down at this, at the molecule, at the ethanol, we can see what's happened is that the double bond from the carbon, the hydrogens come off, and the double bond is now with the oxygen. and obviously then we have something left over. What do we have left over then? Let's take a look. In the ethanol, we've got 1, 2, 3, 4 hydrogens. We've got 1 oxygen, and here we've got, in this ethanol, we've got 1, 2, 3, 4. So, plus nothing. So this means that the vinyl alcohol and ethanol are isomers. Question 2C asks why PVOH can't be made from vinyl alcohol, and the problem with vinyl alcohol is that it's unstable, and it changes very quickly from the ethanol to the ethanol. So this reaction happens very quickly, and so we can't use it to make anything. As soon as we make the vinyl alcohol, then we see that it breaks down, it changes its formula. These double bonded carbons, they're not very happy, whereas oxygen's quite happy with a double bond and goes and makes the isomer ethanol. Let's go on to question 3. Question 3 says, in addition polymerization, the polymer contains the same monomer joined together many times to form a polymer. The polymer has the same empirical formula as the monomer. And then you're asked for 3A, you're asked to write an equation to show the formation of the addition polymer polyethene. Okay, so we start with ethene. And again, the name should give it to you. You know that somewhere there's a double bonded carbon. The basic molecular formula is C2H4. And from that ethene, we know there's a double bond there. And so we can see that that will be the basic formula of ethene. And of course we're going to need lots of these, and we use the N. And if we polymerize, so this is polymerization, and of course we're going to use that handy double bond between the carbons, so they can now have a single bond and then another bond onto the other carbons. We still have our hydrogens, of course. And once again we need to wrap it in brackets and show N. 3B asks, what is the empirical formula of PVOH? Now we were given, so 3B, we're given in the text this, we're going to CH2, CH with an OH, that makes it an alcohol again, and we know that's N. And so if we count these up, we can see 2 carbon atoms, we can see 4 hydrogens and 1 oxygen. So the basic formula of PVOH is C2H4O. On to the last question, question 4. And this asks you for arguments for and against the use of PVOH. There are various arguments. let's have a look. Let's say for PVOH and against PVOH. For, of course, it's easy to dispose of, breaks down quickly. There's no washing involved, you don't know washing. So, for example, no pollution from detergents. If you think of it in comparison to cotton in comparison to PVOH takes a long time to decompose. So those are some arguments for the use of PVOH. Against, of course, it uses a non-renewable source. Of course, this is oil. As the calculation is that we reached peak oil, the maximum oil production way back in 2005, 2006. Calculations vary, but it's a non-renewable resource that we use for PVOH. And if we compare it again to cotton, cotton is renewable. In other words, we can use it again and make a little more clothes from it. So those are some of the arguments for and against the use of PVOH.